In the traditional design world, an engineer would typically design a model using many, if not hundreds, of features. Now, once the design is finished, they then would take it into simulation to make sure the design does not yield under its working stresses. In the next few minutes, you will see the next generation of design where simulation is taken into account during the initial stages of the design. So let's have a look. We start with this Bonina sewing machine where we turn off the cover so we can see the drive system. The drive system is supported by this frame that you can see, a feature-based design modeled in Solid Edge. By using generative design, we can create a basic shape, such as the shape you see here, and let generative design do the design work for us. So let's see how this works. Now, once we've in-place activated into the frame design, we'll go ahead and turn off the background components. And you'll notice at the top the new generative design menu bar. Now, the process is to first apply a material from the material table, then create a study. Then you can begin defining any areas of the model you choose to preserve. Now, in this example, we'll select some holes that are critical for the mounting purposes as well as clearance for the drive system. There are other options to apply manufacturing settings such as internal voids and overhang prevention. And of course, another important step is to set up the simulation loads and constraints that will be taken into account during the generation of the model. Before generating the study, you can see the study quality can be adjusted from coarse to fine on this top slider bar. Also is the ability to reduce the mass by a certain percentage. Now, this particular model takes a few minutes to run. So to save that time, we've already generated the results for you to review. So let's go back and activate that study so you can actually view the results from this. Notice the results and the high quality of the generated model. Also notice the color overlay showing the stress validation. Blue, of course, showing low stress, and red being high stress areas. Also notice that the preserved regions were maintained. Generative design gives us the best design right from the start. Let's take another look at this particular process in real time using the linkage in the drive system. I'm going to zoom up on that part right here. Different than the previous generated model where we started with a block material, here we'll start with a more completed model. So we'll use generative design to optimize our design. Once we get into the part, we can start by defining the material we're going to use, create the study, and then apply a force to the lower hole in the model with an offset, which also helps to preserve the whole feature. We can also quickly apply a fixed constraint to the top hole, and then we're ready to run the generate. Now, for this example, we're going to reduce the mass of this model by about 15%, while taking into consideration the simulation loads and constraints. And what generative design will do here is reduce or remove material from the actual model and provide us with the results where it's removed 15%. Also taking into consideration the loads and constraints that we applied. Comes back and gives us extra information, but you can see that it does provide us with results. Here we can simply press the Show Stress button to review the stresses on the model. Back at the top level, once we activate this so that it appears in our design, You notice how it fits right in our design, just as you would expect. Generative design helps to minimize material costs and yet provides a high-quality design ready for 3D printing. Here's both of our new designs in our assembly. When working with the generative design model, understand that the model is a mesh data model. Although it is ready for additive manufacturing, there may be a need to make modifications to that data. Not a problem in Solid Edge ST10, as we can use convergent modeling techniques to make those changes. Here we're using a live section, which gives us a cross-section of the mesh model wherever it's placed. If the live section is moved, the cross-section updates as you would expect. Let's use the cross-section to project and offset the inner hole sketch as we're doing here. All we have to do is key in a value to offset, pick a side, create the sketch. Notice a region is created that we can then use to create a counterbore for a bushing. Making changes to the mesh model is a seamless process to help you get the results you're looking for very quickly. The future of design has arrived in generative design, now available in Solid Edge ST10.